Hey guys, we're going to look at problems 19 through 20 on review 2. This is dealing with composition. The reason I know it's composition is because of the little open circle. Let's see if I can kind of zoom in. It seems like it's having a hard time focusing whenever I have it zoomed out. So this is composition P of G of X. What does this mean? Well, this is P of G of X. This means we're going to put our G function inside of our P function. So every place we have an X and P, like right here, you're going to take the whole G function and plug it in there. You might be asking, well, how do I know which one to plug in which? So always the letter that's closest to the X, that's going to be your input into the other function. So this whole thing acts like the input. So that's P of 7x plus 2. They gave us these two functions. You can't do these problems without them giving you two functions. So then that means every place I have an x in the P function, I'm going to put in 7x plus 2. So that's going to be -3 times 7x plus 2 plus 5. And then I simply distribute and combine my like terms. And so that's going to give me -21x minus 6 plus 5. And so I end with -21x minus 1. So P of G of X equals -21x minus 1. This is linear, so it makes my domain all real numbers. So again, let's do a quick recap. My G function was acting like the input for my P function. And so you just plug it into your X's and you distribute and combine your like terms. Let's look at the next problem. Now notice the difference in the presentation here. The first part looks exactly the same. It's composition, P of G, those are the same. But now just notice now there's a value in the place where the X was. So how do I interpret this, or how do I make sense of this? This is a smidge more complicated, and the P of G of 3, what this says in plain English is you're going to put a 3 into your G function, right? That's called our input, and we're going to put that in our G function. So let me show you what that looks like. That's going to be P of, we're going to put a 3 in our G function. Remember, this is our G function. So it's going to say 7 times 3, because that's my input, plus 2. Let's figure out what that is. Remember, that input's going to give us an output. So P, we have 21 plus 2, which gives me P of 23. Take that in for a minute. Where'd the 23 come from? Well, that was our output from G of 3. So now look at this notation. P of 23 would now imply that 23 is the input into our P function. So that 23 is actually playing dual roles. It's an output from the G function, and it's also the input into the P function. So now what does this look like? Well, my P function was -3x plus 5. So this is going to look like -3 times 23 plus 5. And that gives us, when you just put that whole thing in your calculator, because there's no variables, that gives you -64. -64. And so P of G, our original problem, P of G of 3 is -64. Okay, let's look at, what about G of P of X? How do we process this problem? No numbers here, so it kind of goes back to the other style where the P will be my input into the g function. So what does this mean? Well, my g function is 7 plus 2, but now instead of seeing the original problem, which was 7x plus 2, now every place I have an x in my g function, I want to put the whole p function. So that would be negative 3x plus 5. And now you simply distribute and combine like terms. So you have negative 21x plus 35 plus 2, which gives me negative 21x plus 37. And that's my answer. I'll write it a little bit cleaner. G of p of x equals negative 21x plus 37. Hope this helps with composition.